So now that we've configured an IP address in Ubuntu, let's go ahead and take a look at the Ubuntu name resolution process. So we're going to start by looking at the content of the etc nsswitch configuration file. So here's our command, cat /etc/ns switch.conf. And this will let us view our configuration file. So here we see example configuration file for the name service switch functionality. Okay, here's what I want you to focus on. Right here for hosts, this is going to resolve host names. And it says files DNS. So what that means is we're going to look in a specific file. We've already looked at it in a previous video. It's the etc host file. So we're going to look there, and then if we can't find the name resolution there, the IP address for the name we're trying to resolve, then we'll look up DNS. Now you can switch that order. There's really not a reason to. We're normally just fine going with this particular sequence. So let's take a look at that file again real quick. So let's cat /etc/hosts, and here's our file. And you'll see the way this file is structured. We'll have the IP address, and then we'll have the name that resolves to. So if I try to access a particular device, let me say I wanted to ping www.microsoft.com. I'm isolated at the moment, so it's not going to work. The first thing it would do is it would look up here in this hosts file and see if it can find www.microsoft.com. If it can, then it will use that IP address and it will try to communicate with it. If it can't find it here, then it's going to go to the DNS system and it's going to try to find www.microsoft.com there. Now, if we want to look at that, that's handled by, let me clear the screen here so we have less to worry about, systemd-resolve. So this is the resolver, and I want to look at the status for the systemd resolver. And you're going to see here we've got 35 lines. Here's our global address resolution. That doesn't come into play. What we're looking for is this. For link 2, which is our Ethernet, current scopes are DNS. This is our DNS servers, 10.1.1.10, 10.1.1.11. And that's our current DNS servers. And that's what we configured. To get out of here, by the way, you'll hit Q. That's what we configured when we set our net plan. Cat / yeah, I'm already in the net plan folder, but whatever. etc net plan. And remember, this one was 00-installer-config.yaml. Now remember, yours might have a slightly different name, so make sure you look up the right name by doing an ls for etc net plan. All right. So once I've found the file, I display the file, and this is where you can see that I set the addresses for my name servers. So that's how I configured that. Okay. Now, what does all this have to do with anything? This is the process that Ubuntu Server is going to go through for name resolution. It's going to go through files first, and that's going to be the etc host file. And then if it can't find the answer there, can't resolve the name there, then it's going to go to DNS, and it's going to contact the DNS servers that are configured here in our net plan. Or if we didn't specify them, if it's a DHCP system, we need to go to the systemd resolved status to view our current DNS servers. So that's where we'll start troubleshooting name resolution issues. Now, one thing to be aware of is you typically don't want to play with the host file a whole lot. For one thing, that host file is only relevant to this machine. So if you've got 27 Ubuntu devices in your network and you're trying to handle name resolution through host files, it's going to get really annoying really quick because you're going to have to adjust every single one of them. So that's why we use DNS for centralized name resolution. However, we can use the host file to overwrite, because we look at host file first, then DNS, we can use the host file to override DNS name resolution. So if we wanted to put in something that wasn't in our DNS server, or if we wanted to redirect something, for example, I was working at a client once, and just as a joke, they wanted to make it so that one of their employees couldn't check his fantasy football team on ESPN. So we went into his host file and we directed that ESPN.com to another IP address. And then every time he would try to go to ESPN.com, it would resolve through the host file first, never go to DNS, and it would take the address from the host file and redirect him to a different site. So you can use it kind of as, as a practical joke thing like we did. You can also use it kind of as a security thing. It's not real strong, but it can kind of dissuade people if you want to keep them away from specific sites. Let's say you wanted to keep people off of Facebook, you could redirect facebook.com to a loopback address, and then it would just crash anytime they tried to open it. Or you could redirect them to an address of a web server that reminds them of company computer use policies. So there are things like that that you can do with that host file. It's not something we'll work with a whole lot, but it is something that gives us some interesting options if we want to customize, let's say, the way that our systems handle name resolution.